Hi folks, we're going to take a look at page 498, number 15. So they give us the equation of these two lines. And in part A, they want us to find the point of intersection A. So this seems to imply that there is going to be a point of intersection, but we still have to make sure we do all our checks and balances. And then in part B, they want us to find the vector equation of a line that's perpendicular to both of these given lines and that passes through A. Okay, so hopefully remember how we're going to accomplish this, but we'll take a look at it as we solve part B. Okay, so let's start by finding the point of intersection. So since we're looking for a point, so an x, y, z, that is the same on both of these lines, we're going to use that and use the parametric form of these lines to create some equations so we can solve the system. So we'll start with equating the x components. So here the x component of a point on the first line is given by -1 plus 5s. Okay, and that has to be to the equal to the x component on the second line, so 4 plus 0t. Okay, and this is where here I realize this is an easier problem than what we've solved before, because with this first equation, I can right off the bat solve for what s has to be equal to. Okay, normally we have to do two equations and two unknowns. This worked out quite nicely. So if I bring the -1 to the other side, I get 5 divided by 5, so s has to be equal to 1. Okay, so now when I use the y components, 3 minus 2s, I can actually input what the s value is. It's equal to 1. Okay, and that's going to be equal to -1 plus 2t. But again, I can now just solve for t. So 2t is equal to, so 3 minus 2 is 1, plus 1 is 2, so t is also going to need to be equal to 1. Now, of course, these values just make the first two components equal. Even though I sense there should be a point of intersection, I still have to check the z values. So I'm going to check z1 using s. So 2 plus 10s, so 2 plus 10 times s, which is 1. So that's equal to 12. And now I'm going to check z2. So 1 plus 11t. So 1 plus 11 times t, and t was also equal to 1, and again, we get 12. So that means there is indeed a point of intersection. We already know the z value. All right, so let's find the rest of the point of intersection. So A, the point of intersection, is equal to, okay, so let's check the x value. Well, we already found out from the second line that x has to be equal to 4. So that's done. Okay, for the y value here, well, we can either use this, which we already found, 3 minus 2 is 1, or we could stick 1 into this equation, -1 plus 2, 1, so whichever one we use, and we already find that the z value has to be equal to 12. Okay, so there's our point of intersection. So now let's find the vector equation of this line. So if I've got two lines, okay, and I'm looking for another line which is perpendicular to both, well, this is where we said, hey, we can take the direction vectors of the two given lines and take the cross product, and that's going to give us a vector perpendicular to both of those lines, hence those vectors, hence also perpendicular to both lines. All right, so the cross product of the two direction vectors is going to give us something which will work as a direction vector for the line that I'm looking for. So let's calculate that cross product here. So we've got 5, -2, 10. Make sure you're working with the direction vectors and not the points. And here's 0 to 11. Okay, 5 and 0. So what's our cross product? So here we have -22 minus 20. So that's -42. Here we have 10 times 0 is 0 minus 55. Okay, and here we've got, sorry, that's -55. And then here we've got 10 minus 0, so 10. All right, so this is going to act as my direction vector. Can't really simplify this, so I might as well use this vector here. And I also have the point, which is on the line, because they told me that this point of intersection was on the line. So now I can just give the equation. It's the point 4, 1, 12 plus, I guess we've already used s and t, so we'll use maybe p, plus p times the direction vector, negative 42, negative 55, 10, and we should specify that P can be any real number. All right. So step one here was to find the point of intersection. We did that by equating the components of the two lines. Okay, it turned out to be a little easier than before. Okay, once we had the point, we were able to determine a line perpendicular to these two by taking the cross product of the original direction vectors, and that gave me a vector that could be used as a direction vector for my line. Okay, that's it for this one.